So for my engineering statistics final project, I decided to test a balsa wood airplane to see what the optimal launch configuration is. So I designed an experiment and I ran 30 tests on it, and so I'll walk you through the data for that. But my general conclusion was that the most influential factors to pay attention to are not the launch angle, but how fast you throw it and how high it is when you throw it. All right, so since this is for my engineering statistics final project, I have to do a lot of analysis for this plane launch scenario. And so here you can see are all of the tests I did. I have a total of 30 tests, but that is only a small part of the amount of data analysis that I had to do, as you can see. So let me just walk through. I know this looks really intimidating, but it's really not that bad, but it definitely did take a lot of time to do. So up here, first, I reorganized the data. So each one of these is all of the data that was over here, but it's reorganized so that I can take an average, because I did 3 repetitions for each pattern just so I could take an average. And I sorted them by the different attributes that I was measuring. So I was checking to see the angle from the horizontal, the speed that we launched at, and then the altitude that we launched from. So those are my 3 variables, and so that's why I've sorted by 3, so there are 3 different sections here. And then I was able to create these graphs from those. I'm able to now compare the launch angle and how that on average affected the distance that the plane went. Or I can look at how the launch speed affected the distance, or the launch altitude affecting the distance, launch angle, speed, and altitude affecting the airtime of the plane. Okay, and so then I was able to condense those graphs into this one right here. So that has all of that same information about how everything affected everything else. And then because that's a little bit hard to see, I just expanded it out into these 2 separate graphs. All right, so then I went over here and I wanted to see how my data spread out and how well in control of the process I was during the testing. And so I took the time of every single test and I plotted it, and as you can see, it doesn't look like there's very much of a pattern. It just kind of goes straight across, so that looks pretty good. It would be bad if we saw it like wandering up or down during the test. Here is so that was for the distance, and then here's the amount of airtime that I got versus the time that I tested it, and again, it's just kind of spread all over the place. That's good. I did the same thing versus the test number. And then I also have the average and the standard deviation in here, and that's what these little bars mean. And so the closer together the bars are, that means the more precise my measuring was. And as you can see, a lot of these, the bars are almost invisible, which is really, really good. That means my numbers were very precise, which is helpful for the rest of the analysis. Throughout testing, I took a couple baseline tests, which were every once in a while, I did the exact same test another time and then marked it. And so what you can see is when I launched with the same altitude, speed, and angle, over time, the average distance that the plane went got shorter, and the average airtime got a little bit less. And so I'm going to guess that over the course of the experiment and the 30 tests I did, my rubber band stretched out a little bit and wasn't quite as powerful. So this is not a super steep trend, but in general, it looks like maybe just a little bit my rubber band stretched out. So that's just kind of cool to be able to see. And if we really cared about it, we could incorporate that change into the rest of the data, but I don't think it's that important for this. Okay, so next we have these means plot. The mean is just the average. And so I was able to see with a low or a high angle how much that affects the distance in general. Apparently the speed of the plane didn't actually affect the distance very much overall, which kind of makes sense because when the speed was small, the plane didn't go very far, and when the speed was high, the plane went up and down, so it didn't go very far. So probably somewhere in the middle is the sweet spot. Anyway, so those are nice general summaries that we can look at. And then I wanted to see the interactions between all these different variables. And so by interactions, I mean that sometimes your variables may be affecting other things without you, or so that they compound. So this is showing how much for example, when we're looking at the speed that we launched and the altitude that we launched from, apparently those both affected the distance the same. And so what that means is the speed does not interact with the altitude because they have the same slope. Whereas in this case, it looks like if we have a higher speed, then a lower angle is going to give even more distance and then a higher angle will give even less. So that describes the interaction, and these are for distance, and then I also have all of the same graphs for the airtime over here. And that's it. That's everything.